All right, welcome to Robbie's Office Hours, Existence and Uniqueness for Nonlinear ODEs. Okay, so this question is very simple. Does this initial value problem, y prime equals t over y squared, where y of 1 is 3, have a unique solution? Okay, well, the answer is either yes or no, but ultimately that doesn't really matter, right? Like you could just flip a coin and say yes or no, and half the time you're going to be right, half the time you're going to be wrong. At the end of the day, you want to know why, okay? Why is it true that it either does or does not, okay? Now, there's a theorem that governs this entire thing. And what does the theorem say? Okay, the theorem says the following. It says you look at something that looks like y prime is some function of t and y. Okay, given the initial conditions, y of t naught is equal to y naught. Okay, that's the starting point for this whole thing. Now, in our example, f of t comma y is just the right-hand side. So this is t over y squared. Okay, that's fine. Now, the theorem, okay, here's the theorem. It says that if f and the partial of f with respect to y, okay, so the partial derivative of f with respect to y, f is a function of two variables, t and y, so it makes sense to take its partial derivative with respect to one of them, in this case it's the y, okay, if f and df dy are continuous in an open set, okay, containing the point t naught y naught, then solutions exist and are unique. Then solutions exist and are unique. Okay? So really effectively what this boils down to is it says, look, find f, okay, done, that was kind of given to me. Find the partial of f with respect to y. Okay, so how do I do that? Well, I can think of this as like ty to the minus 2. And when I differentiate with respect to one variable, I think of all the other variables as constants. Okay, so I'm thinking of t as a constant, and I'm saying differentiate this with respect to y. Well, the power rule just tells me bring the negative 2 down and decrease it. So this will be what? Minus 2t over y cubed. Okay, writing it without a negative exponent. So that's how partial derivatives work. And then I say, okay, well then identify the point here. The point is 1, 3. All right, so it says go to your yt plane. Okay, so here's my t-axis, here's my y-axis. Locate the point 1, 3. Okay, so this is 1, 1, 2, 3. There's the point 1, 3. Okay. And it says look for an open set, okay, so you could just put like a little kind of disc around this thing, but it's not allowed to have a boundary, so it's kind of like a fuzzy boundary, or a rectangle or triangle, whatever, just some open set, such that f and df dy are continuous. Well, what I notice is that f and df dy are continuous everywhere except for when y equals 0. So as long as I avoid y equals 0, so i.e. the t-axis, I'm good. Okay, so I could do something like, okay, I could do something like this. That's my corresponding rectangle. Or you could stick some, sort of like, I don't know, some disc around this or whatever you want to call it. I don't care. As long as this thing does not contain any point on the t-axis, then I'm good. All right, so what's the answer? The answer is yes. Okay, but why? Okay, well, that rectangle, so the rectangle plus the theorem says so. Okay? It's kind of a terrible answer, and it's kind of a terrible way to write it. Okay? But at the end of the day, that's sufficient. Okay? If you're working at a job, for example, like let's say you're, I don't know, trading stocks or whatever the case may be, right? And you're asked the question like, what is the next one that I should buy? And you're like, we should buy $100 million of, stock A, whatever the case may be. Well, the question is going to be why, for goodness sakes. Like, why am I going to pump $100 million into stock A? Like, you'd better have a justified reason, right? So the answer up here is yes or no. But at the end of the day, I don't care about yes or no. I care about the why more than anything. Okay? So here, this gives you an example on how to determine existence or uniqueness for nonlinear first-order ODEs. Again, like, subscribe, share with your friends, comment down below, ask me questions. These are your office hours at the end of the day, and we'll keep going forward.